The third group of galaxies with active galactic nuclei are so-called quasars for quasi-stellar radio sources. In the 60s, astronomers have detected what looked to be stars, but they were unusual. Here is a photograph of one of those that were discovered early, 3C273. It's a Cambridge catalog. They were unusual because they looked like stars, but they were also emitting a lot of energy in the form of radio waves. And normal stars like our sun, or any other star that we know of, does not emit much energy at radio waves. Okay, so that was puzzling. What kind of star is that that also emits a lot of energy at radio waves? Also, what was discovered at the time when the spectral analysis was done, they found the spectral lines of no known chemical element. There were a certain set of lines that did not correspond to any previously known chemical element. Okay? And then it was realized by American astronomer Martin Schmidt that basically those spectral lines are just hydrogen spectral lines, but redshifted by a huge amount. Okay? So if the Hubble law applies, right, that large redshift implies their great distance from us. The redshifts that were observed correspond to the distances of several billion light years, perhaps 10 billion light years. But how can we see a star through a telescope that is so distant? It's crazy, right? And to see it, it has to emit an amount of energy at optical wavelengths that is 10 to 1,000 times greater than the energy emitted by one entire galaxy. So astronomers realized that these objects are not stars. They just appear to be stars. But they are something different. They are also parts of the nuclei of very distant galaxies. So as I hinted before, a model that is used to explain these active galaxies or their active nuclei is something like this. Here we have one extremely massive black hole whose mass is, as I write here, several hundred million solar masses or even billion solar masses. So this black circle here illustrates only the event horizon of this black hole, right? And because it's so massive, the Schwarzschild radius is huge, right? Remember the relationship between the radius of the event horizon and the mass of the black hole. Its radius in kilometers is 3 times the mass of the black hole in solar units. So you're talking about Schwarzschild radius that is several 100 million kilometers or billion kilometers across, simply because the central object is so massive. And around it, there is so-called accretion disk, which consists of gas, dust, and stars. Now, the gravitational force in the vicinity of the event horizon is so strong that actually tears objects apart and accelerates them towards the event horizon. And these accelerating charges then produce the radiation that we observe at various parts of the spectrum. In addition, they emit the jets of charged particles in the direction perpendicular to this accretion disk. Okay? And it is not understood yet why these jets appear, but you can see this is more recent photograph, I believe, of this particular quasar you can see here one of those jets coming out. Right? So why these galaxies all of a sudden become active and start emitting lots of radiation is not quite well understood.